Welcome back everyone. Last time we explored the basics of Python variables and various data types. If you haven't seen that video yet, I will recommend you first check out that to build a solid foundation. And in our today's video, we are going to talk about Python's numerical data types. These are the types you will use when you are playing with numbers, performing calculations, and analyzing data. But before moving further, don't forget to subscribe and hit the notification bell so you don't miss any of my updates. And I would love to hear your thoughts in the comments below. Let us get the conversation going there. And now let us dive into the fascinating world of numbers in Python with some practical examples, essential tips, and last but not the least, questions to test your understanding. Then Python's numerical data types. Actually, they are the types which are used extensively for mathematical operations like addition, subtraction, multiplication, and divisions. Python doesn't just offer one but several numerical types including integers, floats, complex numbers, and more. Integers are your go-to for whole numbers, both positive and negative as well as zero. They are represented by the int data types in Python, but Python normally deduces them automatically. Here are some examples like x is equal to 10, you don't need to specify like this is int. Python will automatically tell that it is an integer. Y is equal to -5, you can assign minus numbers, and you can also assign 0 just like z is equal to 0. Floating point numbers are a number with decimal points. For example, 3.14, they are represented by float, but you don't need to specify them explicitly. Python will automatically deduce their types. Here are some of the ways to define floating point numbers like a is equal to 3.14, b is equal to -2.5, just like integers you can also specify negative floating point numbers. And when you are dealing with large numbers, then you can use underscore to group the digits and make them easier to read. For example, the age of the universe might be represented as 14 underscore 000 underscore 000, then again underscore 000. This grouping doesn't affect the value, and Python will print 14 and all those zeros ignoring the underscores. You can place underscores anywhere you find them helpful. 1000, 1 underscore 000 or 10 underscore 00 all are same, and this feature applies to both integers and floats. Then there is another data type which is known as complex numbers, which has both real and imaginary part, and they are actually crucial in fields like scientific computing. And in Python, imaginary part is marked by j. Don't use anything else than j. Python will throw you with an error. So you can define complex numbers as d is equal to 2 plus 3j, where 2 is real number and 3 is imaginary part. E is equal to -4j, where there is not any real number but imaginary part is -4. Same way you can define f. Now you might be wondering, where are those complex numbers used? Then let me tell you that they are used in signal processing for representing signals with amplitude and phase components. They are used in control systems for transfer functions, and they are also used in quantum mechanics to describe the wave functions of particles. If you are not dealing in these fields, then you don't need to worry about, but just please keep in mind that there is also another type which is represented by Python, that is complex numbers. And decimals, actually when precision is a key, especially in financial calculations, then Python's decimal type steps in to provide high precision calculations. Actually, in those financial sectors, Python's default data type float is not so helpful. So you must use decimal, but please keep in mind this is not a default data type supported by Python. So you will need to import it from the decimal module or package. We will come soon on package, but let's see how you can use decimal numbers. Then this is the first statement where you specify that I want to use decimal module. After that you can specify your decimal numbers like a is equal to decimal and then 1. And now we talked about this decimal module or package. Then you might be wondering, what is a Python package? Then Python package actually is a collection of code written by someone else that you can use in your own programs. It significantly enhances productivity and efficiency in your program, because if you want to use that feature, then you don't have to write that code again. You can use that feature in your code. And secondly, it's already tested multiple times and thus saving time in testing. If it is still somewhat confusing, then let us understand it with an example. Suppose you want to add a feature to your program that requires working with dates and times. To do this, you can simply import datetime package into your Python script using from datetime and then import datetime. This allows you to access the current date time using getCurrentDate and then printCurrentDate, and which will output the current date at this particular time. We will discuss more on Python packages later on, like how to write a package, install it, use it in the future. For now, just remember that they are the collection of useful code that make your programming life easier. Then we talked about two different types of floating point numbers or decimal numbers. One is Python's default types, that is float, another is Python's decimal module. Then what is the basic difference between them? Why use decimal if floats are already available? Then let me tell you, precision and rounding. The key difference lies in precision and rounding behavior. Floats are the default for decimal numbers in Python, but they offer limited precision, which can lead to rounding errors, especially with very large or very small numbers, which are very crucial in fields like scientific computation or financial sectors. To understand precision, just take a look at this simple division where I am trying to divide A by B and then it outputs something like 0.33 but this is very limited precision. Now compare it with the decimal type. Import the decimal module first and then let's define two numbers, decimal numbers A and B, and then divide C is equal to A by B. Number might be looking same like float in the left side, 1 divided by 3, but when you print the output, then you can see this output is much bigger than floating point number. So decimals can represent decimal values more accurately due to their design, making them invaluable in fields like finance and science, where precision is very much important. Another point to keep in mind is that while floats are faster and they use less memory, but their precision issues can be a drawback. On the other hand, decimals, even if they provide more precision, but they are slower and more memory intensive. So, choosing between floats and decimal depend on your specific need, whether speed and efficiency is required or accuracy and precision are more critical for your application. Then sometimes you need to convert data type from one type to another. This is called as type conversion. Keep in mind that this can be particularly useful when you want to perform operations that require uniformity in data type. And Python provides several built-in functions to facilitate this, such as int, float, and complex for working with numerical data types. And we will delve deeper into these and how to use it and when to use these conversions in our upcoming videos. Python also supports Boolean data types or Boolean values, which represents true or false statements. And they are the fundamental aspects of any programming language. And these types of values or variables are designated by the bool data type. Here is how you can set these Boolean values. You can simply define a variable and then after this you can specify true or false. Then Boolean has a lot of applications in Python, actually in any programming language. Just like decisions are intrinsic part of our life, same way Booleans helps in making various decisions in any programming language, including Python. And there are a few ways in which Booleans can be used in Python. And first is logical operations. Here you combine Booleans with logical operators like AND, or NOT to evaluate various kind of conditions. Just let me tell you that we are not going to discuss these right now, what are these operators or other aspects. I am just giving you an overview where Booleans can be used and how they can be helpful. In type conversion, Boolean values can be easily converted to other numerical types. For example, true becomes 1 when converted to an integer and false becomes 0. Same way 0 becomes false or any non-zero value becomes true. Booleans are often also used in control statements to guide the flow of execution in your program, such as in if statement, while loop, and for loops. Boolean also work alongside comparison operators like double equal to, not equal to, less than, greater than, or all of these values, all of these operators to compare values and making decisions based on these comparisons. And don't worry if you don't understand what are logical operators or control statements, etc., because we will cover all of these constructs later in our future videos. And now, here are a few questions based on our discussions on today's topic. You can find solutions to these questions on my GitHub page and I have already given a link of that page in the description below. And that's a wrap on our journey through Python's numeric data types. And don't forget to subscribe and hit the bell icon to stay updated with our Python series. Stay tuned for our next video where we will dive into Python's string data types. We will cover everything from basic string operations to more complex manipulations and functions that make handling text data like a child's play. Whether you are dealing with user input, data processing, or simply automating everyday tasks, mastering strings is crucial. And if you enjoyed this video and learned something new, then please give it a thumbs up. I would love to hear from you. Drop a comment below if you have any questions or share your experiences. And thanks for watching, and see you in the next video where we unravel the mysteries of Python strings. Till then, happy coding and have a nice day. Bye bye.